Let's take a look at the software challenges in your company. If you see a Software Engineering 2012 white paper issued by NIPA, we can see the importance of the competitiveness of the software through comparison of Apple and Samsung. Apple has achieved a $52 billion revenue, operating profit of $19 billion from fiscal year 2012 quarter 1 performance. Samsung Electronics in fourth quarter announced consolidated sales of $47 billion, operating profit of $5.2 billion in 2012. It can be seen that Apple, which is only focusing in IT devices, such as the iPhone, was ahead of Samsung sales with a full lineup in the semiconductor, LCD, mobile phones, home appliances. In particular, we can see Apple is much ahead, even in the operating profit 4 times higher than Samsung. So you can see that Apple is ahead of Samsung both in terms of gross sales and substance. What major causes to make such a difference? The answer is that Apple has been building various software application-based content ecosystems. Apple overcomes their weakness, which they operate only in their platform, with various services to customers. As we see the data, we can realize that how important software competitiveness of enterprises are in recent days. Recently, software significantly takes important role and increase their size, and predict that in the future, the size and complexity of software increases exponentially. As the dependency to software get increased, in parallel, there are needs that software quality should be improved, such as correctness and reliability. But we actually overlook for the social and economic problems and costs caused by quality problems, such as software defects. Therefore, it's now time to reduce the social and economic damage caused by the fault of the software and prepare a plan or approach to improve the competitiveness of the IT convergence products. In particular, we have the situation where it is required to put more our interests and efforts to secure global software quality competitiveness, given the reality of local software enterprises in the small domestic market struggling to compete with global corporations. Let's continue the people, processes, technologies, aspects of issues related to software development. The development issues related to people is firstly, new employees have different competency levels from the past. Secondly, morale of software workforce is low due to hardware-centric environment. And thirdly, organizational knowledge is leaked due to frequent staff turnover. And also, other problems, which is the common concern of software developers, are included in development issues. They are complaining about the low position of software in company and the working style conflict between senior and juniors due to different generation, concerning on lack of career vision. For example, we have no vision. And raise a problem in poor work environments that require work until 9 p.m. at 9 a.m. Take a look at the following issues in the development process point of view. Most organizations have developed software with ad hoc manner or repeat development with rework. Therefore, the effect on the introduction of new technology is generally insufficient. An organization that generates a lot of benefits does not really care about the process improvement because they think they are the best, and there is no reason to do additional work to get better. In the case of managers, a lack of understanding about the importance of process because they think the most important is sales and revenue. For developers, they have a sense that the process makes additional overhead, so that they have a lack of the motivation to participate in the process improvement. Finally, having the issues of the technology aspect, there are problems in that to apply software engineering techniques and methods in practice, also using case tools, applying global standards and a systematic reuse practices is insufficient. Leading companies recognize that software development is very important. These companies evaluate their software development maturity periodically and looking for improvement opportunities and prioritize improvement activities and carry out execution plans to move. This is the summary data related to software configuration management, which carried out in a local mid-sized company in the past. When evaluating any company's capabilities, it usually diagnoses three perspectives. The first is process, the second, technology, and the third is person. For each of the three aspects, regarding process issues found, we saw this company had a lack of configuration management policies and process definition, and there was inconsistent execution in their real practices. Regarding technology issues, tools and best practices for configuration management were not well integrated. For people issues, there were a lack of knowledge and competency development for developers. These problems are not just limited to this company. Process is not defined. Process was poor even if there was a defined process. Tools are in place, but we can frequently see developer skills, understanding, and deployment are generally poor. Look at the developer side. Importance of configuration management, how should configuration management does, how to manage the source code, how to manage breaches, how to manage releases, and how to do check-in and check-out are not well established. These should be done with general common rules, but as there are insufficient training or awareness, they are not well integrated and each play separately. So, companies are looking to find the problems and derive the implications of the problem. For example, this company needed policy and process concepts and definition, and improved CM support tool features and performance improvement to be able to operate in automating workflow-based CM processes. From people aspect, there should be a need to set up the CM dedicated team to foster the developer's configuration management capabilities and knowledge to maintain CM systems. This company found the implications and prioritized based on impacts and importance, developed the action plans, and finally executed an action plan to improve the configuration management process. Now, shall we look at some things that are related to myths that manager and customers and software developers have? Managers think developers have everything they need to develop software if they have advanced case tools, standards, and procedures. And they think developers don't need standards and tools because developers work hard and put their best. When project behind schedule, they think they can catch up to the schedule if they add more developers to the project. They think good managers can also manage the project well. As the software is not visible, they think it should be enough to check the start and end. For customers, they think that it's enough to start software development once we get the outlines. It's okay that the detail can be developed later. They have myths that changes to requirements and are easy as software itself is flexible and developers make decisions themselves then execute project. For developers, they have myths that their job is complete the program and developed and run. They think that there is no way to assess the quality until the program is run. Working programs are only project deliverables, and Case Tool solves their problem. Now, what would be the answers to address these problems, complexity, and/or challenges? We are seeking to find the answers from software engineering to successfully develop the software, which is increasing the sizes and functionalities. The application of software engineering is more important than others as systemic management, software engineering techniques to provide a techniques that support the efficient work performed address anticipated difficulties throughout the process up to the maintenance from the requirements analysis. The companies realize and need the importance of software engineering. In the past, from the way of coding first and fixing later. Now the companies get more recognition on that it is important to define and analyze requirements. In order to effectively apply software engineering techniques, 3 key success factors, which are the definition of systematic practices and workflows that integrate into processes, organizing the workforces with expertise, and infrastructure to operate defined workflows and workforces efficiently should be balanced and harmonized. Then, we can develop software that we want in engineering manner. Also, these three factors are required to be steadily improved and invested with many efforts during the period in which the company operates. Software engineering is not a one-time event, but should proceed as planned and continuous efforts through strong commitment and sponsorship of top management. Then, you can finally achieve the desired results. This is how the birth of software engineering, and explain what is currently the hottest and trendy. Look at the history of software engineering 1950s. Software engineering concepts was adopted to software development projects, which was similar to hardware engineering. As the demand for software surged in the 1960s, it caused a software crisis due to the lack of experience and ability, numerical shortage of manpower to implement it. So then, software engineering earnestly got introduced. Starting in the 1970s, as high demand for software occurred, it became lack of manpower. There were a situation where put a large number of non-majors to resolve the problem. These people typically coded first, then fixed the problems later, leveraging the characteristics of software, which can be easily modified when they developed the software. This approach would make company realize that the gap exists in reality of fast-changing world. Requirements were becoming increasingly apparent, and development teams defined their own requirements themselves. As coding first and fixing later approach made many defects found, and they caused side effects, structured or formal techniques had revealed. Thus, the waterfall model was developed to proceed in order with the analysis, design, implementation, and so on. But formal techniques had difficulties in use for the general software developers. The waterfall model required requirements to be clearly defined at front and start the analysis, development, testing, which such defined requirement, but in reality, there were a lot of changes in the middle of development occurred, because the development typically started with undefined requirements. These impacted the progress slowed down due to high rework and cost overrun. So in 1980s, were tried to address these problems. There were many researches on finding ways to increase software productivity, to develop software effectively to increase the reusability. In 1990, it happened to be a need to shorten the time to market of products for a competitive advantage in the market. This impacted more research on software development productivity, used the model that focused on concurrent engineering to conduct a requirements, design and implementation at the same time in waterfall model. In 2000s, which began to rapidly changing market environment surrounding the software, agile methodologies have been introduced in order to effectively respond to these rapid changes, and you can see many modern companies have been adopting and institutionalizing these agile methods. Software development capabilities is recognized as the key success of companies in the digital age. The companies which understand and prepare the major technology trends get tangible benefits to bridge the execution gap. In fact, 69% of companies that leverage software development to reap the competitive advantage is better performance than any other company in terms of profitability. Therefore, companies should increase software development capabilities in order to enhance the competitiveness of products and services. However, as software development gets more difficulties due to software increases in size, software features diversified, and changes to software operating environment such as user interface, software engineering is required, and at the same time the need for efforts to increase the execution and quality is also necessary. Let's summarize the software statistics in Korea via the 2012 data of NIPA. This statistics was made by NIPA based on results of targeted 255 projects of total 220 companies. In conclusion, we look to see local software engineering capabilities are still very poor. If you look at this chart, it shows 69 point for process, 57 points for workforce, 59 points for technology, and 62 points for overall score out of 100 points in software engineering. In this case, we can see all aspects except for process are very poor, which points to the lowest grade. Looking at the data compared to 2010 to understand how much get improved, we can see process aspect is somewhat improved, but the quality, technology, and workforce are very little relatively improved. What common phenomenon appears in Korea software engineering capability scores between 2009 and 2011? The processes are usually defined as internal policies in many companies, but we can see that they have relatively insufficient quality workforces to efficiently operate and manage processes, and their technology aspect is considerably very poor. Recently, many companies strive to adopt and improve effective processes for software development in order to improve software quality and keep it consistent. The reason to emphasize on software process improvement and adoption in the companies is that it can perform effectively in software development with less investment and can independently proceed with people and technology. Even if outstanding people or technology exist, it is difficult to maximize these capabilities without appropriate processes or understanding. Software process is consisted of a series of steps carried out, activities, tasks, and deliverables as seen on the screen. This will ensure that there is visibility as roles and responsibilities are clearly defined. In addition, this makes easy to plan and track the project and reduce unnecessary work, the starting point for process improvement to enable continuous process improvement in your company. To enable them to continuously improve their software process in the company, they're adopting a various software process improvement models, such as CMMI or SPICE, which helps minimize the development risk and identify improvement opportunities that help a company to increase maturity of organizational development. Let's see the characteristics in the software lifecycle. As said in the beginning, the software lifecycle serves as the backbone in the software project compared to the human. Since it takes the backbone role, depending on which model is selected, the software project tracks right direction or in failure. We should consider it take a very important role to dictate it. In the waterfall model or V model, there are a typical model of the most widely used in the field. The reason is that it is typically the easiest. As analysis, design, implementation, and testing phase progress sequentially, project managers or developers stand to think of something simple and not complicated progress in a series of activities. So, waterfall or V model clearly shows that what process should be performed by project manager or developer, and is fairly easy to understand customers who does not know software development well. But when you see the shortcomings, this is a model that can be applied in the most ideal when user, system, software requirements are clearly identified in advanced details. But in reality, it is almost impossible. Therefore, Agile is recently one of the hottest trends, as it is more appropriate than waterfall because we can see that Agile is most suitable to recent changing development environment. In addition, the waterfall model is a model that emphasizes the verification, validation, and testing. So according to the characteristics of our development environment, as we always emphasize the testing processes, on the other hand, the company considers the waterfall or V model is the most suitable. Let's look at the incremental model. In case of the incremental model, it is a useful model when there is a need to reduce the system development time. After core features are developed and operated first, the rest of the features are implemented and added. This results in the system development via the function expansion through several iterations. Therefore, firstly, let the base system version operate with limited features, and then complete the future system version with add-on features on top of base features of previous versions. So, requirements are already determined, but this is the most useful model in the case that there are possibility of changes or improvement for defined requirements over time. Now, let's look at the evolutionary model. The evolutionary model is a useful model when there is a need to reduce the system development time. Unlike the incremental model we discussed, it is the model to repeat several times to develop the entire systems. It's also a model that each system provides the user with all the features finally. So a system was developed and operated, and changes are derived. These changes are inputs and feedbacks to develop the next system. So this model is fairly similar model to Agile and interactive development, which is one of Agile development methodologies. Because it has similar properties, many companies are using the evolutionary model a lot. It is a model that changes, including changes to the functions, and changes to the user interface, and changes to non-functional requirements, such as reliability and performance improvement, are implemented and reflected to the system as it evolves. In case where system specification is unclear as a whole, it is also the most appropriate model where there are continuous demands for product improvement. There are many cases where mix of incremental and evolutionary models are both adopted in the field. By closing look at the field, several models in hybrid forms are applied, not just only one model. The evolutionary model has the characteristics where software development progresses by adding new features and improving existing features at the same time for new system version. Therefore, such model has the following characteristics. For the evolutionary model, even if the system does not have the full functionality, early training for the system can be delivered. It can also provide initial training for system users, also allow users to become familiar with the system, elicit necessary changes, and reflect those feedbacks into future evolution. So due to the shortening of the development cycle, can be more competitive as the early use of the system. Because the system is developing several times, it is a good model that can address the issues, problems, and risks early. Also, it can be developed by splitting it with professional breakdown. For example, this model can be used that if the project transforms the text-based user interface into graphics-based, a user interface development team first develops certain improvement on user interface, and the other development teams then to proceed and improve the next pieces. Lastly, let's talk about a spiral model. While previous models are to reduce managerial risks, spiral model is to develop many prototypes to reduce the number of technological risks. With this prototype, this model evaluates the technology is really reasonable, can prove the feasibility or, if not, then decide whether it should be disposed or develop another prototype. It would make a decision on whether we changes to project requirements, cancel, or proceed after each of the prototypes has been developed. It is also the model that minimizes the commitment in each phase to find a solution of the technical risks. The spiral model is adequate when there are a dependency on stable system requirements and detailed analysis of technical risks.